everyone, and welcome to lesson 21.2, starting on page 295 in your Springboard textbook. Today we are going to talk about another type of shortcut for right triangles, specifically 30, 60, 90 triangles. So this time on our pattern of our quilt, we see a hexagon divided into 6 equilateral triangles. And we know in an equilateral triangle, all 3 angles are going to be 60 degrees due to this triangle having to have 3 congruent angles. So what happens from here is that we know in this blue triangle specifically that it's cutting our equilateral triangle in half so that each piece in this blue triangle would be 30, since the angles are congruent here in this piece that we're drawing in that is perpendicular to a base. So we have this 30, 60, 90 right triangle that we are going to focus on. Now the longest leg is our hypotenuse still, but the longest piece of our triangle, the hypotenuse. But then we have a longer leg that's always going to be opposite of this 60-degree angle, since that's the bigger angle. This would be the bigger leg, and then the leg across from the 30-degree angle would be the shorter, smaller leg. Okay? Now, if we start looking at patterns similar to what we did in the 45, 45, 90 triangles, we have here our 30, 60, 90 right triangle, right? So I'll put the 30 here and the 60 here. Okay. And in this case, if we know that the hypotenuse is, in this case, 6, we want to know then the length of the shorter leg, the length of the longer leg, and then the ratio of the pieces. So if we go back to this example here, if the hypotenuse here is 6, we know that this whole thing would also be 6, and this would be 6. So if we cut that piece in half, each of these would have to be 3, given the perpendicular bisector nature of this piece we call the altitude. And then what we could use from there is the fact that we can use Pythagorean theorem to find our remaining side, right? 6 squared equals 3 squared plus b squared. 36 minus 9 is 27. And then if we square root 27, we know that 9 times 3 is 27, and 9 is a perfect square. So b would equal 3. We still have a 3 left over, so this would be square root 3 in the house. Okay, so shorter leg is 3. Longer leg would be 3 square root 3. Now the ratio of the longer leg to the shorter leg, so 3 square root 3 compared to 3, we notice this root 3 involved. Now, similar to what we talked about yesterday, the process is going to kind of be the same each time with these. If we change this up so that our hypotenuse is now 8, again, going back to the last page, if that piece was 8, the hypotenuse is 8, all sides of our equilateral triangle would be 8. Thus, each piece here that is going to be 4 and 4. So we notice this pattern each time, that the short leg, the side across from the 30, keeps being 4. And then again, when we do Pythagorean theorem, 4 squared equals 4 squared plus b squared, we have 64 minus 16, so that's 48. And then when we square root, again, we notice this breakdown of 16 times 3, and these are both 4. This is left inside the house, so our remaining leg is 4 square root 3. And again, we see that square root of 3 become a piece of our puzzle. And this is going to keep happening throughout this, okay? If we have a side length of 4, the short leg is going to be half of that. The longer leg would be that times the square root of 3. If we know that the short leg is 3.5, we can double that value to find the hypotenuse, which would be 7. And then we know the longer leg is just the 3.5 times the square root of 3. And then again, if we know the short leg, you could double that to get the hypotenuse. And then our longer leg is the value times the square root of 3. So as we move through this, we see some pieces here that if you are looking for the length of the longer leg, you multiply short leg by the square root of 3. And if you're looking for the hypotenuse length, you multiply the short leg by 2, right? So we see this pattern that the short leg is kind of the important one here because we can either double that value to find the hypotenuse or multiply it by the square root of 3 to get the longer leg, our 60-degree side, across from the 60-degree angle. Okay, so very important that you have this figure drawn into your notes. So a couple of examples with this, and each time it might be helpful to have a 30, 60, 90 triangle drawn out. So I'm going to put this as my 30, this is my 60. So again, we know short leg, long leg. Short legs across from the 30, long legs across from the 60. So they say, okay, they're giving us in this first example, the short leg is 6. So that means over here, we know that our short leg is 6. Well, that's great news because we know to find the longer leg, we're going to just take that value and multiply it by the square root of 3. And to find the hypotenuse, we're going to take this value and double it. So 2 times 6 is 12. So 6 times the square root of 3 inches and 12 inches. In the next example, they're telling us this time about the hypotenuse being 10. So in our picture, our hypotenuse is 10. And again, you can label as 30 and 60. So this time, to find the short leg, we know we need to divide by 2 to get the length of the short leg, which is going to be 5. And then the longer leg is our short leg times the square root of 3. So we find those answers a lot quicker, and really by just knowing one side, we can find the other two in a 30, 60, 90 without even using Pythagorean theorem at all, okay? Then this concludes the notes for today. We will work more with our 30, 60, 90 degree triangles in class. Thanks for watching.